Assalamualaikum and good evening. My name is Muhammad Zulfakar. So for this video, I will explain about the assignment for RF technique and microwave. So my partner is Clarice Mariali. So for our lecturer is Dr. AKM Zakir Hussain. So we move to the low pass design. So this is our question. Cutoff frequency 3.2 GHz, insertion loss is 35 dB and 8.2 GHz, and our ripple is maximally flat. We need to calculate the value of omega and then omega cutoff, omega c. After that, we need to divide omega with omega c and then minus with 1, so we got 1.6. Then we plot the 1.6 at the graph for maximally flat. And then the attenuation we use 35 dB, so n is equal to 5. And then we refer to the table for maximally flat, so n equal to 5, so we use G1 until G5. So this is the value we got from the table. And then for that, after that, we need to calculate the value of capacitor and inductor. And then for our low pass filter, we're gonna design the type of pi network. And then this is the type of pi network. So after we calculate the value that we got from G1, G2, G3, G4, G5, and then the value that we got after calculate, we put inside the circuit. So move to the circuit. So this is the circuit for low pass. So we put the value inside the circuit and then we simulate. Then this is the our output for low pass. And then after we design the low pass, we need to design the Ricci transform. We need to change the circuit to Ricci transform. So we're using the same value G1 until G5, and then we change the value of G1, G3, and G5 by using this formula. And then we got the value here. Then we put inside the Ricci transform. So this is the value for Ricci transform. And then after we design the Ricci transform, we need to calculate this one value at the red line, and then at the red line. So after that, we use this formula to get the value of each part. And then we put the value of 0.38 at Z2, and then Z1 use 0.62. And then after we get the layout like this, so we need to calculate each part of this to get the design for short circuit. So after we calculate, we will get like this. So this is the normalized impedance for this different stub. And then we need to denormalize it by time with 50 ohm. And then after we time, so this is the result that we get after we time with 50 ohm. And then after we time with 50 ohm, we need to design the circuit schematic for this stub. Then we open the circuit. So this is the circuit that we design. And then each value here we need to put at the Z0 to get the value of width and length. We need to calculate of each here, of each the value here. We need to change at the ZO, and then we use 90° for 50 ohm, then we synthesis. So this value at the physical value we will put inside the ML in. So that's the way to find the value of width and length. And then after that we need to we need to simulate to get the result, and then this is the result before tuning. So we don't get the perfect output for low pass, and then we need to tune it to get the perfect low pass output. So we need to simulate. So this is the output for our result for after tuning. So this is the tuning. If the circuit not perfect, and if the result is not perfect, we need to adjust here to get the perfect output. So that's all for tuning. And then we need to, after tuning, we need to design the layout for distribute LP design. So this is the design layout for distribute LP design. So and then we need to find the layout for this circuit. And then that we need to design the bandpass filter. So finish for low pass filter part. So we proceed to bandpass.
So from this LUM design, I'll be explaining regarding the bandpass filter. As you can see, the 3 dB ripple we have taken from the table n equals 4, because from the question that we have been given, the FO is 3.2 gigahertz, n equals 4. That's why we took the value 4 from this table, and the resistor is 50 ohm, ripple is 3 dB, and the bandwidth is 310 mega. And from these values, we have keyed in and calculated for the F1, F2, omega 0, 1, 2, and also gotten the difference. And from the table, we've actually extracted the values of G1, G2, G3, and G4, which is these values that we've placed here. And from that, we've used the values from the table to calculate the T-network low-pass filter prototype to get the inductor and capacitor values, where we have used the resistor value of 50 and also this formula. And from these values, we have keyed into this circuit, which is a low-pass filter circuit with the S parameters at 0 to 4 gigahertz. From that circuit, we have gotten this output, which is a low-pass filter output, and we have placed the marker at negative 3 dB, which is the value that we've gotten. That's very close to the value. And the next thing that we've calculated is the series inductor and also the shunt capacitor. And the values that we've used here is also from the table, and also the values that we've been given to calculate. And with these values, we have keyed into this circuit where the S parameters is 1 to 5 gigahertz. with the step of 0.0 gigahertz. And this is the output, which is for bandpass filter, where we can see the M2 and M1 represents the F2 and F1 that can be calculated to get the bandwidth and the signal that passes through the circuit. And the other areas other than the center one would be the rejected signal. And with this, we've known how to calculate the values for both low pass and band pass, and also identify the difference between a band pass and also a low pass filter based on the design of the circuit, and also the cutoff, the number of cutoff points, which is -3 dB. That's all for me. Thank you.